Hello students. In this video, we will be seeing how to trace parametric equations. Tracing of curves given by parametric equations. Now basically, what are parametric equations? Equations that are dependent on some parameter, or you can say equations that are dependent or one or more independent variables. Such equations are known as parametric equations. Suppose for example x is equal to t, y is equal to t plus 1. Okay, then we say this x and y are dependent on variable t, or you can say dependent on parameter t, and such kind of equations are known as parametric equations. So x equal to f of t and y equal to g of t in general are known as parametric equations. Now as we seen in Cartesian equation how to trace Cartesian equation, there were certain rules. Similarly here we will be seeing certain rules to trace parametric equation. Rule 1 says limitations of the curve. Limitations of the curve, that means find the limit values of the variables x and y depending on the t, or you can say in simple words, find the greatest and the lowest value of x and y with respect to or for some proper value of t. Okay, what this will give? This will give us the boundary values, or you can say this will tell us between which values the curve will lie. Second rule says symmetry. Now again, symmetry depends on certain conditions. First condition says if f of t is an even function and g of t is an odd function, that is if x is an even function and y is an odd function, then it is symmetrical about x-axis. Or you can say if we replace t by minus t and if we get back the same value of x, or you can say x remains unchanged but y has the same but opposite value, then we say in such case we say it is going to be symmetrical, curve is going to be symmetrical about x-axis. If f of t is an odd function and g of t is an even function, then we say curve will be symmetrical about y-axis. On the other hand, if you replace t by pi minus t term and you get y unchanged but x has same but opposite value, then we say curve is symmetrical about y-axis. So there you can use any one of this condition to check the symmetrical about x-axis or y-axis. That means there are two ways to check the symmetry of x and y-axis. Next there says if both functions f of t and g of t are odd, then the curve will be symmetrical in opposite quadrants. As here it is, for example, x is equal to c of t, y equal to c upon t. Both are odd functions, symmetrical in opposite quadrants. Next rule says find the point of intersection. Points of intersection, again as we seen, with respect to x-axis, with respect to y-axis, check whether it is passing through origin or not. So again, to check whether it is the curve passes through origin or not, find such value of t for which x and y both are 0. If you obtain such value, then we say curve passes through origin. Then check whether the curve passes through or intersects coordinate axis, that is x-axis and y-axis. Next rule says find the special points, or you can find more points which can be easily detected or which can help us to trace the curve easily, and then find whether there exists some tangent at this point. How do we find a tangent? We find a tangent by finding the value of dy by dx. If dy by dx is equal to 0, we say tangent is parallel to x-axis. If dy by dx is equal to infinity, we say the tangent is parallel to y-axis at that particular point. But this was either directly we would find dy by dx if we have function y equal to f of x. Now here we have function as x equal to f of t and y equal to g of t, that is x and y are dependent on t. So obviously dy by dx can be written as dy by dt upon dx by dt, and hence you can find the tangents parallel to x-axis or parallel to y-axis. Rule 5 says region of absence of curve, that is find the region where the curve does not exist. Find those regions where the curve does not exist. Now Yeah, here we know that x and y are depending on t. So obviously the values for x and y will vary with respect to t. So it will be better to make a tabular form, make a table for values of t, check how xy and dy by dx varies, and that will help us to trace the curve easily. Okay, note down that if both x and y are periodic functions of t with a common period, we need to study the position of the curve for one period only. So if you observe x and y are periodic functions and both have same period, we can study for the curve for one period only. Okay, next we see one definition. The definition, that is cycloid. What is a cycloid? Cycloid is nothing but a circular circular roll along a plane, along a straight line drawn by a fixed point. Okay, when a circle rolls in a plane along a given straight line, then the locus traced out by a fixed point on the circumference of rolling circle is called a cycloid. Suppose you are having x and y axis. Suppose x is the fixed straight line, and there is some fixed point which rolls along this x-axis, then the locus which is traced out by this point is known as a cycloid. Okay, it will be more clear when we will see an example. Okay, now let's see an example of parametric equation. Now here the question says, trace the curve x raised to 2 by 3 plus y raised to 2 by 3 equal to a raised to 2 by 3. Now if you observe, this is a Cartesian equation. It is an equation in x and y form, but it is not easier to trace this equation Cartesian. So what do? We convert this equation into parametric equation. So we introduce parameter we introduce parameter t, and we can now write this Cartesian equation and parametric equation as x equal to a cos cube t, y equal to a sin cube t. If you substitute these two values here, you will see this equation will be satisfied. So the parametric equation for this equation are given as x equal to a cos cube t, y equal to a sin cube t. Now first rule, चेक द सिमेट्री अभी चेक करना है, मतलब देखना है कौन सा फंक्शन इवन है, कौन सा फंक्शन ऑड है. अकॉर्डिंगली डिसाइड होगा एक्स एक्सिस से सिमेट्री है, वाई एक्सिस से सिमेट्री. सो नाउ इफ आई रिप्लेस नाउ टी बाय माइनस टी, cos of minus t will be cos t, whereas sin of minus t will be minus sin t. Means we observe x is an even function and y is an odd function. So I can say it will be symmetrical about x axis. But if you also see if I replace t by pi minus t, then cos pi minus t will be minus cos t, whereas sin pi minus t will be sin t. Means x is also, if you substitute t for t and pi minus t, we observe that y remains unchanged but x changes. X changes to its equal but opposite value. Means this says that it is also going to be symmetrical to y-axis. Means this curve, this parametric equation will be symmetrical to both x as well as y-axis. Okay. Now what do? We draw a table and see how this curve varies. So obviously cos and sin are periodic functions of period 2 pi. Okay, so we say how x and y varies for t, 0, pi by 2, pi, 3 pi by 2 and 2 pi. So if at t equal to 0, cos 0 is 1, so x is equal to a. At t equal to pi by 2, cos pi by 2 is 0, so x value is 0. At cos pi is minus 1, so x is minus a, and so on till 2 pi. Similarly, when you substitute t is equal to 0, pi by 2 pi in y, so sin 0 is 0, so y is 0. Then sin pi by 2 is 1, so y is equal to a. Sin pi is again 0, so y is equal to 0. Sin 3 pi by 2 is minus 1, so y is equal to minus a. And for 2 pi, y is equal to 0. So this table tells me the variation of x and y within the period 0 to 2 pi. Okay. We simultaneously draw here. This is suppose x-axis. This is suppose y-axis. Okay. Now we consider with respect to t equal to 0, pi by 2 pi. So I write t equal to 0. Suppose this is pi by 2, pi, 3 pi by 2. Fine. Now how does t varies? If you observe, as t varies from 0 to pi by 2, cos of t is decreasing whereas sin of t is increasing. That is, x is decreasing whereas y is increasing in the interval 0 to pi by 2. And further, if you see the interval pi by 2 to pi, x is again decreasing whereas y is also decreasing. Then pi to 3 pi by 2, it goes from minus a to 0, y goes from 0 to minus a. In 3 pi by 2 to 2 pi, x varies from 0 to 2 pi, y varies from minus a to 0. Okay, so suppose this is a comma 0 minus a comma 0, this is a, that means x and y, their intersection, point of intersection with respect to x and y are a and minus a respectively. So for any value of t, we observe that cos t lies between minus 1 to 1 and also sin t lies between minus 1 to 1. Means ultimately x will lie between minus a to a and y will lie between minus a to a. So obviously this tells us that x and y will not exceed the points A, means there will be no curve beyond the point A for and point x minus a for x. Similarly, the curve will not exist for the point y greater than a and y greater than minus, beyond a and minus a. Okay, so we know now where the curve cuts exactly. We also know how it varies between 0 to pi by 2. Between 0 to pi by 2, x goes from a to 0, means it is decreasing, whereas y is increasing. So I can say this curve will proceed like this. Then from pi by 2 to minus pi, x goes from 0 to minus a, it is more decreasing, and y is also decreasing. So I can say this curve will go decreasing like this. Then pi by 2 to 3 pi by 2, minus a to 0, minus a to 0, it is increasing, whereas with respect to y it is, so this will go like this, and then here like this. Okay, a star shaped curve you can say. So this curve is known as asteroid. So basically asteroid is given by an equation x raised to 2 by 3 plus y raised to 2 by 3 plus a raised to 2 by 3, or x raised to 1 by 3 plus y raised to 1 by 3 equal to a raised to 1 by 3. Parametric equations given as x equal to a cos cube t plus y equal to a sin cube t. So this curve is known as asteroid.